Uh, Hello, guys. Welcome to Computer Science and Engineering Exploration Seminar. I think so far you have been taught a lot of topics. In this week, we are going to talk about computer security. So in software, in the era of software, security is very important. And what kind of topics is there? And also, this course will cover the basic principles and the basic security services and what you're going to learn throughout the computer security class later on. Okay, let me get started with who I am. My name is Hyungjun Koo. I'm now an assistant professor in the Department of Computer Science and Engineering, College of Computing and Informatics here in 성균관 University, SKKU, since 2021. Currently, I'm leading the lab called SEC AI. So mostly, as the name suggests, we are covering security issues and the AI part becomes the important part of our lives. So it's really good timing to think about how the artificial intelligence can get involved with security. So mostly I'm working on practical security. If you think about security, we always, the first thing that we have in mind is attacks and defenses, right? So sort of traditional security, we do deal with the attacks and differences. So practical security is important, but the technologies are getting evolved. So whenever a new technology comes in, then there is a security issue. So we also cover the security for emerging technologies. So for example, there was a time there when we don't have the Wi-Fi technology, right? So now the Wi-Fi wireless network is pretty much common and everybody uses it. But when back then, without the Wi-Fi technology, everything is connected, wired, right? Because of emerging Wi-Fi technology, we should think about the wireless security again, right? So as this kind of the broad area of security is sometimes called the attack surfaces. So the more emerging technologies we have, the larger the security surface, attack surface is, right? And as I said, AI becomes an essential part of our lives. So what would be the best way to apply AI techniques into the security world? So in that sense, we are also interested in AI-assisted security. And sometimes this is called security AI for security. And we also we're interested in secure AI or security for AI, right? Slightly different. So we do have the AI models, then what would be protected against the attacks on AI, right? So these are our interests, and let's talk about the software first. So what is software? As you know, software is a collection of code and data, to perform a specific task. So sometimes software is called a program or an application, right? Um, so I think you have heard of operating system, right? So this is the software. Operating system is another system software that is running on every hardware. So here, software means here you can change the faces. Hardware, once you manufacture the hardware, it's literally hard. So it's really difficult to change it. But software, depending on the code, depending on your programming, then you can change the code, right? And data as well, flexible, right? So when you generate software or an application, and the core of software is coding data, then you can do anything you want. Operating system is a specific special kind of software. And we, in terms of applications, there are tons of different applications. So if you think about Microsoft, I think a lot of users install the Microsoft Windows. And Windows 10, Windows 11, these are, good examples of operating system. Other than Windows, we do have Linux, and we do have other operating system like Mac OS applications, Microsoft Office, Excel, Outlook, PowerPoint, Word. These are all different kind of software. And how does the software how do you generate software? Well, there are two different ways, but mostly let's focus on one type of software. Once the programmer generate the code, and this is called the source code, and there are many different kinds of programming languages. Probably you might have heard of Python language or C programming language, C++, C Sharp, Ruby, Lua, all different kinds of programming languages there. And once you write the source code, then there is a very specific software. This is again software that converts the source code into a program. Here, a program means software or application. And this special software is called compiler. So compiler compiles source code emitting a program. And this program is mostly, the form of this program is an executable. So executable code or executable binary, okay? That's the core part of software. So you don't need to think about software in a difficult way. If you want to install a specific software, right, and then you just download it in executable, and then you double click the executable, then it automatically installs the program, right? So that's the software. And as you see, software is everywhere, not just on your laptop. It now becomes part of our lives. Like, drones. Inside drone, you have to control how to fly, right? Everything is an application inside the drone. Of course, there is an operating system inside, and self-driving cars, right? Now it becomes popular to people, and probably the cryptocurrency. Some of you might invest cryptocurrency, and virtual assistant. This is also, within the virtual assistants, there is a specific software that listens to your voice and understand the voice and then execute your command. So these are different kinds of software, as well as the software or applications in your laptop, and all different kinds of IoT devices. So here IoT stands for Internet of Things, right? Internet of Things. Many different kinds of Internet of Things devices. Satellites, Wi-Fi routers, and home appliances, and so forth. And as I said, software is everywhere. And not just IoT, if you think about the mobile phone, then you have to install a lot of mobile applications. If you're using Android, you should connect to the Google application and then download whatever application you need. If you are a Mac user, then there is another ecosystem to download the applications there. And now the thing is, we have computer and we have IoT devices. The thing is, everything is connected now. So we call this the huge networking, connected all different kinds of computers. We call internet. So someone measures what people are doing on the internet, and this is called the every minute online. I think I forgot to include the link here. So there is a guy who measures what people are doing within a minute on the internet. So if you look at the online activities here, YouTube, within a minute, people are watching the videos as much as 3.47 million videos. Netflix, 452,000 hours streaming. And for the Instagram, people are sharing their photos as many as 66,000. And Facebook, inside the Facebook is another SNS, right? 2.1 million users are active, within minutes. And think about the email, 231 million emails are sent to within a minute. TikTok is another SNS, and people are watching 625 million different videos. So it's a massive amount of activities online within a minute. If you combine everything together on the internet, it becomes very, very large, even hard to imagine, right? So I just draw the big picture of the digital world. Very, very simple, sort of the classic networking is like a client and servers. So we do have our laptop, your workstation. Then if you want to get some services, then you request a service to the servers, and then server responses back to the clients with the service, right? So one of the, good examples would be web service. So if you are connecting to neighbor.com or google.com, then there is a Google server, or there is a neighbor server, and the server responds the clients back, right? Okay, here is the first website. If we go further, within the computer, we do have a lot of people, and these people are log in to use a specific services, and people are connected to each other. Not just the SNS, and also we are using cloud services, because You want to store the data into a single space, right? Which is in cloud, then you can use the same data uh, even though you are using different kind of devices, the mobile devices, the laptop workstation, and just you store your own data on the cloud, and then you can freely use and update, edit, delete those data, right? Files, directories there. And if you think about IoT, Internet of Things also have its own ecosystem, right? The surveillance cameras there, autonomous cars, and other control systems, satellites, and so forth. So these are all the IoT ecosystems. And these systems might use the cloud services, might use the specific servers, and these are all connected to each other. So now, the reason why I mentioned, these slides, software important, and I think there is another topic, AI, because AI is also important. And here, as I said, here, internet, everything is connected. So this makes security very, very important. So let's move on why security matters then. Security is essential because it becomes an increasing part of our business, social, and personal life that involves internet-based computer systems. Okay, so if the security does not guarantee the safety of our lives, then what happens? What happens is we may lose a lot of money. So here, enormous economic damages from security incidents. I think that's this statistics came from the past. I think 4 or 5 years ago, at least more than that. So the United States estimates that at least there were 100 or more billion dollars a year from cybercrime. And there were numerous victims, including both individuals and companies, organizations, and numerous victims there. Probably you have heard of the ransomware. I don't know there is anyone who were infected by ransomware. Ransomware is sort of the malware, malicious software. Malware stands for malicious software that attempts to encrypt the user's documentations, right? With the encryption. So, for example, once your computer is infected by ransomware, then all your presentation slides, all your documents, PDF files, all kinds of your homework assignments, these are encrypted and automatically encrypted without your consent, and then the ransomware takes this as a ransom, then requests the money to you. Do you want to decrypt this documentation? Then you should pay for it, right? That's ransom, right? So documentation, the encrypted documentation would be ransom. And as a victim, so those documentations are really important for you, right? It matters to you. Then, so well, how do we do? Do we have to pay for it to the attackers, right? So this is just the example, but security becomes really, really important. So let me start with the case study. Probably you might not have heard of this specific malware. Stuxnet is a malware, and this malware um, is known as the world's first digital weapon. And there is an article, there's an unpresented look at Stuxnet back in 2014. So I'm not going into too much details, but the main idea is now, the powerful countries start to leverage the malware into weaponizing, um, um, you know, weaponizing them, and then, attack another country using malware. So Stuxnet is a really, you know, good example of this. Who was behind, and this is known as the United States behind, and the United States government generated this malware to uh, stop the generating the uranium in Iran. So I'm not going into too much, and if you're interested, please, um, you know, Google what the Stuxnet is for. So the idea is now people, I mean at the country level, start to, uh, use this kind of digital weapons. And many different sectors are also affected by, cyber attacks. So here, various sectors means the first one here on the left side. This article says millions of Anthem customers targeted in cyber attack, and here Anthem is one of the biggest insurance companies in the United States. And this means the cyber attacks targets the insurance company. I think it happens back in 2015, almost 10 years ago, right? That was a long time ago, but still this is happening. And this is not it, right? This is financial sector, insurance, right? And the other sector is government. Also, the hackers, cyber attacks also targets the government. Government's computers are also hacked. And in this article, around 10 years ago, again, these computers are exposed, and 21 million people's information was breached. So that's a huge amount of data information, right? Also, they target airplanes. Here on the left side, you can see the article, hackers crowned 1,400 passengers in attack on airplanes' computers. They attack the airplanes' computers, and they are using a specific malware or any attack methods to cause the blackouts of the city. So this is an example that happens in Ukraine. It led Ukrainian blackout because of the hacking, and also not just this kind of specific country or the organization. It's a really wide, national wide, and it doesn't choose a specific organization or country. There is the attack called also called APT, and this kind of threat is very, very unique. And this is a APT attack, or advanced persistent threat. So here, the more advanced attack is like this. So you target a specific organization or you target a specific country, then you just stay there. You can attack a specific system and wait until the time comes. Okay. So, and it does not target, many people. Just target a specific person, a specific organization, or a specific country. And because of this stealthiness, pretty difficult to get the sample of this malware. Probably it involves with malware anyways. So that's why this is called advanced persistent threats. And also this is another kind of another class of attacks. Okay, let me move on. It's not working. Let's see. Um, okay. And another case study. Data breaches is also a huge problem. This is one visualization about the amount of, depending on the amount of data breaches. So here, the large circle represents the more information, the more data breaches, okay? So back in 2021, there was, I forgot the number, but there was a huge number of data breaches. And, a few years back, Facebook has a huge number of data breaches. So it's not just, these days, the hacking is not just for fun. Instead, they want to monetize it. So they want to make money. So once you take out those information, the data or information, and then they want to sell the information to the black markets, right? And then they can make money. That's the core objective of these attacks, okay? And it's not uncommon to have this kind of news, right? So every year we get the news that a huge company has data breaches. I remember there was another data breaches these days. I think a few months ago from even Google, and so all kinds of huge companies, including Facebook, LinkedIn, Google, Yahoo, which is gone in history, Twitter, and these services have a lot of users, right? And once the accidents involves data breaches and the impact is huge. All right. Not just security part. Privacy is also important. Privacy. Okay. Let me remove this one. Okay, remove this one. Okay. So the privacy also matters. Why? Because now it's difficult to think your life separately from the cyberspace now. So people started to think that our lives should be respected in cyberspace. So cyberbullying it's a huge crime. And privacy in terms of privacy, people started to claim that, okay, I need to have a right in a cyberspace, which is the right to be let alone. Don't touch me, right? I want to be alone. And once you post something or someone else posted the information or news or data about you, right? And the data is there, right? Like forever, as long as the internet is alive. And it's really difficult to remove, the private information once it's breached out because, the data can be easily replicated. So people started to claim that, okay, I need to have a right to be forgotten. Please forget me. This is not me. This is not what I did, right? Probably now, after the internet was born, so the first generation still, after the internet was born, still we have the first generation. First generation means a lot of people who started to use the internet has not been dead, right? They're all still working, they're living, right, with the cyberspace. But after the first generation started to go out, I mean, after 100 years, then, people started to die. Then still, the dead people's information is there in a cyberspace. So it's really important to think about the right to be forgotten. I need to, I need to, I need to be forgotten by others. Um, so this is sort of the new rights and the ability of individual. Okay, what is the capability of the individual in a cyberspace? So the main idea is to respect people in our cyberspace, just like the space we live in. Okay. So regarding privacy, we have a few case studies. I think I've heard of a few instances about the celebrity hacking. Here celebrity includes sportsmen, the entertainers, and movie stars, and all kinds of people who are public, right? So once they hack the celebrities' accounts, that could be a huge thing because these are influencers, right? And the way they talk, the way they post, the figures, pictures they posted, these are very important. And people, these people's behaviors and way of thinking could impact a lot of people. So it's almost 10 years ago again to countermeasure the security of the private information. Apple says they will add a new iCloud security measures after celebrity hack, right? So the new security scheme becomes available after an unprecedented instance happened. And another case study says it's possible to trace individuals with the data itself, right? So like the companies that runs the social networking services, SNS, including Facebook, X, the former Twitter, all kinds of the SNS services. And because they have a lot of information about the individuals, once they have sort of the collective information, then they could do a lot of things. So on the left side here, if you look at the title here, armed with Facebook likes alone, researchers can tell your race, gender, and sexual orientation, right? Because you just click likes here, not just Facebook. Once you have a huge amount of information about this individual, then it's possible to infer that what kind of type of this person. Because if this guy says I'm interested in man or woman, then probably it's likely that he's man or she's a woman, right? And there is a statistics to support, the race. Um, is this guy the racism or not by looking at the likes? And this is not just looking at a single instance. Instead, a huge data collection. Now you have the statistics available, and the gender, the political preferences, by looking at the likes. Is this guy on the left or on the right, right? This is very important in terms of privacy. So there are many people who do not want to reveal their preferences, right? Race, gender, um, political preferences, right? There are many things. So what can the company do with this information? Um, they could sell this information to the advertisement companies, meaning that they could monetize them, right? This is a huge problem. And on the right side, attention shoppers store is tracking your cell, right? So here in the video, so I think that was a long time ago. Now I don't know what the privacy becomes stronger, or is there any rules or regulations with respect to the privacy? But at the very time, the technology says, okay, we can now trace the customer by having the camera on top in a shop, right? So this guy is walking through this line, right? And they started to, collect the big data, uh, and then who is watching what item and how long they stand in front of which, product, and eventually what item was sold by someone, right? So all these things can be traced out, but without your consent. That would be a problem, right? So it's possible to track the individuals, and these are the privacy problem. Okay, so far we cover a lot of case studies in terms of security and privacy. So what is the nature of security then? I want to say three different natures of security. One is the security is a people problem. So security problem, when you say security problem, always it entails the people. So, easily we can think of attackers, right? There's attack, there's a victim, attacker attacks the victim, and there is a defender who tries to defend against attacker, and even so, probably we have an instance, right? Then there are people again who tries to find the answer why this instance happens. And these people are called investigators. So security, in security, this is all about people problem. Attackers, victims, defenders, and investigators. So this means that if we don't have any people, then there is no security problem. So what security do we need if there is no people, right? And another nature is we say security is as strong as the weakest link, and people are often recognized as the weakest link. So here, we're going to talk about the chain later on. Wait. Here, actually, security, the nature of security is combined with the trust, and this is called trust chain. And these are trust relationship, and I'm trusting with this guy or this device or this technology, and this technology has some trust relationship with another technology or person or anything. And these trust relationships are chaining together, and now you all trust everything. Now on the left side, let's say A, let's say here A and B. In security, we often mention Alice and Bob, just like Chul-soo and Young-hee in Korean, right? Two major names. Alice and Bob, when they trust together, why do we need this one? Because this is invisible. So from the Alice perspective, she can't see the Bob, and Bob's perspective, he can't see Alice, right? Because this is cyberspace, and it's possible to talk to anyone regardless of the distance and time. That's what the cyberspace is for, right? At night, you can send a message, right? To your parents, for example. And when you type messages to your parents, there are just a single activity, right? When you type, let's say with your mobile phone, you type the message, then the thing is, how do you trust your mobile? So when you type A or you type B, how do you trust that your mobile phone actually recognized you are typing A and B? What if the other characters will be sent to the response, right? The responder. So these things are all chained together, and everything is trust. And often the weakest link in this chain is people, right? So people don't trust each other, or with the blackmailing people, then it's easy to get the information. For example, if you want to know the password or passcode in your bank, what is the password code for this bank, for example? Then when you typed all different kinds of combination of the numbers, let's say if you want to withdraw the money, then you should type 4 different digits numbers. Then the number of attempts that you have to do is a huge number, right? But if you threaten people, right? Threaten people, blackmail people, a person who possesses that bank account, what is your password? Then you can threat him and you get the password immediately without having much effort. So that's the problem, right? And this kind of thing is called social engineering, okay? Impersonation. The other nature of security is the process. What kind of process? endless process. So as an organization or as a country or as an individual, you have to mitigate the risk, right? So what is risk? We're going to talk about what the risk is in the later slides. But anyways, when we say risk, you know what that means, right? So we can't get rid of the risk, that we should mitigate the risk. Mitigating means that you should decrease the size of the risk. But if one deals with a huge organization or many people, then it's a really complex. And the risk is not just a single vector, it's involves with a lot of different vectors, even including laws and regulations and technical difficulties and people who have different interests, and so forth. And in security, we say there is no single solution that can solve all security challenges. And we usually say there's no silver bullet. So silver bullet is the bullet in a gun, right? The bullet that addresses every issue. There's no such thing when it comes to security. We can go through difficult jobs, difficult tasks only through the process. The process could be a complex process, and it should be updated again and again depending on the situation. Because we should always deal with emerging technologies, and always we have new attack vectors. This is something I mentioned earlier, right? Attack surfaces with the emerging technologies, attack surfaces is broadening, and that means there is a new attack vector, then there is new defense mechanism needed, right? So we should upgrade, these security mechanisms and mitigations throughout the process, endless way. Otherwise, it's pretty hard. Again, there is no such silver bullet. Another thing, the last thing, I think this should be 3. Right. As I said, this is about trust chain. So trust chain is a matter of trusting what or who, or what and who, right? So this trust is based on the assumption of trust relationship. So who can you trust to, or what can you trust with? Can you trust the system? Can you trust the policy? Can you trust the people, right? So to support the trust chain, there are many different things we provide, such as certificates, signatures, digital signatures, or infrastructures. This is the introduction course. I'm not going into too much details about how the trust chain is working, but this plays an essential role in security. So now we talked about the nature of security, and let's talk about what makes security difficult. Now we have all kinds of mitigation techniques. Now we recognize what kind of attacks is available, but what makes security so challenging, right? First thing is inherent asymmetry in terms of information between attackers and defenders. So here, asymmetry is the opposite word of symmetry, right? That means attackers requires a very small information For example, adversaries requires to find a single security hole, and then they can successfully, inflate the system. However, from the defender's perspective, the guards need to protect every single design and implementation, which is a more and more difficult. And also the defenders should be able to think about the normal operations. And it's okay to have the security mechanisms, but it does not disturb people, disturb the original operations, disturb markets, right? So for example, everyone knows the importance of password. So, okay, now we have a password policy, right? So the password policy says, to strengthen your password, please set up your password at least 100 letters long. Does it make sense? No, it does not, right? Why? Because you can't even remember 100 long passwords. You can't remember that. And it takes too much time to type 100 long passwords every single time when you sign in. So from that perspective, the usability is very bad, right? That's why we have usable security as well. So we can somehow strengthen the password by, increasing the number of letters, but it can't be infinitive. But to a certain amount, you can't make this, even though the longer passwords, the better, but we can't have the password too long, in length. So we have to think about many things from the defender's perspective, unlike attackers. Attackers finds a single security hole and attack it and success, and that's it. But from defender's perspective, it's pretty challenging to have a single shot defense mechanism because of the inherent asymmetry. Another thing is as I said, security is just merely as strong as the weakest link. Even though you have the trust chain, you have a very strong chain between two relationships, and this trust and the other trust, everything is very, very, strong, but there is just the one link which is very weak, then the whole security is just that strong, as strong as that weakest link. Because once you break that link and the whole security chain, the trust chain will be broken, right? And as I mentioned earlier, oftentimes the weakest link is a human, social engineering, right? So one example is that about the social engineering is that when an attacker wants to enter the building, and let's suppose that the building requires a password. Then an attacker just pretends to be a boss of that company. For example, you just call the building guards and say, okay, I'm the CEO of this company, then just let me in. This is in order. Then probably the building guards might be deceived, right? Because otherwise he could be fired, because even though he does not guarantee that the voice over the phone is actually boss, but this kind of trick is really, you know, it goes very well. And this kind of attack using a human is social engineering. We do have the side channel attacks. Side channel is the channel that we do not desire to do. Like, for example, one example of side channel is the energy consumption, right? So when you type a letter, right, type a letter, then if you don't know the password, then you can't log in. But somehow there is a specific device that can measure the power consumption. It's a very special, device, right? And then when you type a letter, then depending on how you implement the 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 authentication mechanism, it's possible to guess that a certain letter is part of the passwords or a certain letter is not part of the password. So this is called the side channel. So measuring the electronic, or microwaves, I mean the waves, electronic waves, measuring those waves is not something that we think of, right? When you design or implement the security mitigation. Another thing is it's difficult to recognize malicious intent. The malicious intent, meaning that how do you know someone's mind, right? I did that for good purpose. If someone insists that, then probably we just think, okay, that was your intent, then it should be fine. But it's really difficult to recognize such intent. The last attributes that makes security challenging is the complexity of the modern systems. And if you think about the modern software or system, it's too complex to understand for a single person because nowadays software is not usually implemented by a single user. A lot of developers are working together and write code and compile and generate the executable. But a lot of code relies on the library. So your library is the collection of code, which is very well written by others. This is not our code, the developer's code, but it just exposes the API called Application Programming Interface. So that means every code inside the library, everything is a black box. You don't know how implemented, right? But the only thing you know is how to use the API. So for example, you don't know how to compute, let's say, mathematical operations like a log operation. You don't know how to, let's say, you don't know how to implement it, the log, log, right? But we can rely on a mathematical library that implements log, right? Throughout the API, then we can just invoke the API call to the library, then you just get back, okay, this is log 7. This is the value of log 7. So as a developer, just you use the the actual the features. So rely on external library, rely on external framework, rely on other codes. This is pretty common these days. So that means it's very likely that even a programmer doesn't know the whole code. how it works. He or she doesn't have, it's almost impossible to have the whole knowledge of how the software works, even though they borrow the code, right? And because of too complicated code, that means there are a lot of execution paths. There is an area called software testing. So because there are so many execution paths, it's almost infeasible to go into every different path for checking if these paths are safe or unsafe, right? So the number of paths is not just millions or billions, and the amount is it's like, you know, the huge number that we can't even imagine. So like 2 to the 100, 2 to the power of 100. 2 to the power of 100 is the number that even we can't even imagine. It's really large number. And that's many execution paths, and there's no way to check out every single path, right? And again, because modern software is too complex, writing bug-free code is almost impossible. So here, if you look at the line of code or LLC, and LLVM is the compiler, and Linux kernel is kernel, Chromium is a web browser, and these are very old version. So the modern LLVM compiler, Linux kernel, or the browser has much more lines of code. But still, very long time ago, look at the line of code. So the VM compiler, more than it's around 4.4 million, and kernel 25 million, and the browser 32 million lines of code. 32 million lines of code. I think the current version has, at least 50% or more than this. This is my hypothesis. But the idea is the system or software is too complex, and lines of code, it's really huge that it's almost impossible to go into all the paths to see if those paths are safe. Okay. Okay. So far, I talked about the nature of security and why security is so challenging, right? So I talked about the three things, right? So keep that in mind, and then let's move on. So the next topic I want to go through as security services. Now, let's talk about, okay, we know the security is difficult. We know security is essential. We know the nature of security. Then how do you do it? That's the next question. So what kind of security services do we have to provide? Okay. So there are, a number of security services, but here, these services are the main security services, and almost all kinds of services should provide at least one of these services. Confidentiality, integrity, availability, and these three are called the CIA. And also, let's talk about authentication, authorization, and non-repudiation. Okay, these are the security services. So let's begin with confidentiality. So what is confidentiality? This is the service that protect data from unauthorized disclosure. So, as I said, now let me introduce two people. One, Alice, and the other one, Bob. Alice and Bob. So suppose that in a cyberspace, it's obvious that we do not see each other, right? So because physically we do not sit, facing each other. So Alice and Bob tries to talk to each other over the network, and it's possible over the network, right? So if you think about the internet is network of network. Over the network, there are many different people out there. So remember the whole internet looks like there are IoT devices, the cloud services, servers and clients, and SNSs. So people are sitting, watching the video and trying to do some banking transactions, and a lot of things are going on over the network. And there are obviously malicious users, not just malware. Let's say the one in the middle here. So this guy is Carol. So it says Carol. Carol is bad guy. And it's possible for the bad guy to, look at your data. And this is called unauthorized disclosure. So if Alice sent the message to Bob, and Alice desires to expose her message to Bob only, not Carol or not anyone else, because the message is supposed to reveal to Bob, right? But if these messages are in plain text, so plain text meaning it's not encrypted, okay? Anyone can read the message over the network. Then it's possible to eavesdrop, right? This message. Eavesdrop is 도청 in Korean. And we sometimes say sniffing. Sometimes not just eavesdrop these messages, the bad guy can also illegally copy those messages, store those messages into other storages. So the first security service that we should be able to provide is confidentiality. Okay. Sometimes we say Kim Il-sung in Korean for better understanding. And this is confidentiality. Let's move on to the next one. And the other security service is integrity. What integrity aims for is to preserve data from illegal modification. So again, the carrier is sitting over the network. If he could eavesdrop the message, then it's possible to intercept these messages, and he can modify this message and resend the modified message to Bob again. And this is sometimes called the man-in-the-middle attack. So literally, this attacker is sitting in the middle, right? This is the guy, the man in the middle, and intercept the messages and send it to the recipients by tampering and releasing the message. And this is something that we want to block, right? So we want to preserve the data. So suppose that Alice told Bob is, for example, I want to borrow the money from you. I need $100. So in this case, the attacker says instead of $100, what if this guy changes the message to $1,000? And then Bob thinks that, okay, the Alice wants to have $1,000. And then he sends the thousand, let's say $1,000. And then this guy intercept the message again. Somehow he, take out $900 and send it back to the $100 Alice. This could be problematic, right? This could be very problematic. But in real life, I just simplify things. But this could be happening, right? So now we say security service should offer integrity. Integrity should provide, the original data, and by blocking illegal alterations. Another thing is availability. Wait, by the way, integrity is in Korean is called 무결성. Okay, 무결성. And another thing is availability. Again, in Korea, we say 가용성. So availability is the property. So whenever Alice wants to talk to Bob, then he should be able to. That's the availability. So always the system should be maintaining the service so that the legitimate users can use it. So I think you have heard of denial of service, DOS attack, or distributed DOS attack, or DDoS, right? So these are the good examples to subvert the availability. So the third security service is availability. Okay. And these three security services are called the CIA triad. Triad looks like this, right? These are triad. And one, confidentiality and integrity and availability. And CIA is not the CIA that you know of. Okay. So the C represent confidentiality, I represent integrity, and A represents availability. And this is a basic model that represent main security services. The other one is authentication. As I just put these words together, authentication and authorization, but these two terms are slightly different. And there is another term called access control. So authentication is, if you think about the login system, then that's the authentication, okay? So once you log into the system, the system asks you your credentials, what is your ID and what is your password. So by providing your credential, ID and password, then system knows that, okay, this is you, right? So this is the service that you are the right guy who you claim to be. That's the authentication service. But authorization is slightly different. Usually, the authorization is the privilege or the permission of the grant that can be given to someone, okay? The grant to someone, subject or object. So here subject means a person, object is an object. It's not non-person. So if you are authorized, right? Authorized. So as I said, this is usually the grant for the subject, and the object has some kind of permission. Let's say you can read this file, or you can write this file, or you can execute the file. This is one of the good examples. Then once you log in successful, then now the subject has some permission that what kind of authorization does this guy have, depending on object. So is this guy have the reading permission to read this file? Okay, so that's the concept of authorization. So if you could think about, let's say, once providing, your credentials to Windows system, for example, but the Windows system does not allow you read all kinds of files as a user. If you are privileged user, then you can be. But if you are a normal user, non-privileged user, then it's possible to log into the system with the authentication service. But from the authorizations perspective, you don't have all the grants to read the files. There are a few files that you can read. Some files you do not have the readable permission, right? That's the concept of authentication and authorization. And access control is sort of the metrics that have what kind of permissions you have depending on subject and object. That's the access control. And usually the access control can be represented with access control metrics, or ACM. So these are the concept of security services. And again, suppose that we have Alice and Bob, then over the network, then there is Carol in the middle, the bad guy. Without Alice's contact to Bob, the Carol pretends to be Alice. He tries to steal the identity. He tries to get access to unauthorized object. For example, here, he pretends to be Alice and approaches to Bob, right? This is the problem. And the security services should be able to provide these services: authentication, authorization, and access control. Okay. The last thing is, okay. So speaking of authentication, let's think about the authentication schemes. There are three main schemes. One, knowledge base. So knowledge-based authentication is based on what you know. Okay, sometimes we say possession base. The knowledge base, sorry. So one good example would be passwords, security questions, right? These are the knowledge base. If you know your own password, if you know the answer for the security questions, that's good. But the downsides of the knowledge-based authentication schemes is you can forget things, or passwords can be reusable. Once the password is breached, then the reusable password would be risky. And even though the person does not know any information of the password, it could be guessable, right? So the attacker can guess your password. If the attacker has more information about you, then the guess would be more easy. Could be combination of, let's say, your birthday, then he could, try some birthday-based passwords. So this is the knowledge-based authentication schemes. The other one is possession-based. So this is all about what you have. So possession, meaning that what kind of things you have. For example, phone, or a card, token, or badges. If you possess those things, then you will be authenticated by a system. right? The phone, then you can, I think now you have the multiple factors of the authentication schemes. So in Google, once you provide your credentials, ID and password, then if you activate two factor authentication, then the Google asks you to check if you are the right guy by providing the number in your phone. So only the one who possesses your phone can answer the question, right? So that's the possession-based scheme. But the downside is that you may those things might be stolen, might be lost, and sometimes it might be duplicated. Okay. The last one is based on biometric. So biometric-based schemes is about what you are. So it utilizes your fingerprint, your face, your iris, your voice, right? These biometric things is very good because it has very unique property. However, the downsides are it might be less acceptable. People don't like it to show your face, probably, or iris or voice could be, and the device to recognize those biometrics might be very costly. And sometimes even you have your own voice, but your voice can be gone, right? So that could be another downside. And this could be somewhat spoofable, right? Probably there is a people who has very similar voice to you, right? The face might be very similar. Think about twins, right? Somewhat spoofable. Fingerprint also can be somewhat spoofable. All right, so these are the basic authentication schemes, right? Knowledge-based, possession-based, and biometric-based. The last security service we're going to talk is non-repudiation. Okay. So what is non-repudiation? Non-repudiation service is about avoiding the dispute of an authorship or validity. So what does this mean? So for example, Alice and Bob talking to each other, but without any Carol in the middle. Let's say there is no attacker here. But Alice says something, but later on she could deny what she said. That's the repudiation, right? And for example, Alice says, "I sent money to you yesterday," and Bob answered, "I have not received your money yet," but we don't know the truth. So let's say, "What are you talking about?" from the Alice side, and Bob said, "Send it to me immediately." Okay. But Alice might be lying. She didn't send the money yesterday, or Bob might be lying, even though the Alice already sent the money. But Bob says, "Okay, I have not received your money yet." So we could have some dispute over these two people, and this is called non-repudiation. And in Korean, we call this 부인 방지. Okay, you should not deny what you said. You should not deny what you mentioned. I think I did not mention about in Korean this one. So authentication is 인증 in Korean. Authorization is 인가. Access control is in Korean. We say 접근 통제. Okay. I think this might be helpful to understand better the terms. All right, this is the last essential security concepts. Moving on, let's talk about assets, threats, vulnerabilities, attacks, and risks. So I think that these are the last concepts that we are going to deal with. Okay. So what are assets? A set is a valuable target to be protected. So a set of targets that you want to protect from the attackers. It could be data, it could be systems, it could be networks, or it could be applications, software. And threats is the potential danger that causes harm or incident. So threats are something that have not been occurred yet, right? So that's why we say potential danger. The hackers, they are threats, even though they didn't attack you, but they are there. Insider threats, right? They are threatening from inside the organization. Malware is prevalent all around us, but it's still before attacking our machine. But malware is there. These are threats. And we say a potential danger that may cause harm or instance at some point. So we need to modeling the threats. And the modeling threats or threat models are a set of assumptions about plausible attacks. And the system should protect your asset, right? So here there is asset, and we have threat, and we do have to model those threats against the possible attacks. And understanding potential threats is very crucial for taking appropriate measures. And there are various threat modeling approaches. So we are not going into too much details, but attacker-oriented model, software-oriented model, or asset-oriented model. Okay, so just you know, there are different types of threat models. Okay, let's moving on to vulnerabilities. Vulnerabilities, a vulnerability is a weakness in a system. Okay, a weakness in a system, software, or process enabling a threat. Okay. So, you know, there are many software vulnerabilities. So vulnerability is one type of a bug, right? So as I said, because of very complex system, we can check out every, you know, different paths and every different inputs. So there might have bug. So in previous slides, we said it's really difficult to have the bug-free implementation, bug-free system. So vulnerability is sort of a subset of a bug that could trigger a real threat. So that could trigger the actual security incident. That's the vulnerability. So one, I want to, you know, show one example. So back in 2014, almost 10 years ago, we have the heartbleed bug. And we say it's a bug, but with using this bug, the server can be exploited with this vulnerability. And this bug type is a vulnerability. So I'm not going into too much detail about what it does, but the idea is that there is client on the right side, there is a server on the right side, a client on the left side, sorry, a server on the right side, and they are talking to each other, and here, what kind of messages are they sent is basically heartbleed bug is on the encryption software. So it's called OpenSSL. So we didn't talk about what SSL is. Anyways, this is the library that provides confidentiality with encryption and decryption. So particularly on the website, right? So on the client side and server, if every message between the client side and server is in plain text that anybody, the carrier, can reveal the message, read the message, intercept the message, that's possible. So that's why on the web protocol, everything, every message should be encrypted. OpenSSL does the encryption and decryption. This is a library. Okay. But the thing is, if you use OpenSSL, the web protocol is based on the messages between clients and server. And whenever server recognizes client, then client should bring a certain information. Sometimes we said it's cookie, this kind of things. So whenever you bring this information to authenticate this client for the server, it has some burden. So OpenSSL implements the heartbleed. Sorry, this is not heartbleed. It's not bleeding. Heartbeat inside the implementation. It implements a heart beating. It's like a beating between client and server. There is no transactions. Then just the client side send some messages that server to reduce the overhead, right? So every a certain moment, the client just keeps sending, okay, I'm alive here, I'm here. So what kind of overhead can we reduce? I will not talk about that. But anyways, client keeps sending a certain message. That's the part of the implementation, heartbeat. But the idea is what kind of message is there? Just say, oh, okay, what do you have? So are you still there? Can you see? If you're ready, if so, answer me 3 letters, for example, or 500 letters. And the server reads 500 letters and responds it back, right? But the bug is the number of letters are not well defined. So the server has just to read the number of letters the client sent. So whatever message is within the server's memory, it just responds back. So this could leak a very sensitive information. Okay, that was the bug. It's very, at a high level, it's that simple. So this kind of thing is a vulnerability. So what kind of threat is possible? Because, the server has this kind of vulnerability inside this OpenSSL library, then we don't know the actual threat, but there is a threat. This client, suppose that this client is a malicious user, then this guy can send, can manipulate the number of letters here, and asking undesirable amount of letters so that the server can leak the sensitive data. That's the vulnerability. And we do have the vulnerability database because this is so essential, it's so important. And this is called Common Vulnerabilities and Exposures, or CVEs for short. CVE is a list of records that identify publicly known vulnerabilities. And this is sort of the database. So if you go to the cvedetails.com, then you can see quite a few number of CVEs there. Okay. So they have categorized, I think, 10, 11 each different vulnerabilities here, and then over the years, does it, if you look at the number, is it increasing or decreasing? What were the most severe vulnerability? You can roughly decide it, okay? But this does not, the number does not show the comprehensive vulnerabilities. This is reported vulnerabilities, okay? So it would be good to know the CVE and just check it out, this link. Moving on, let's talk about the attacks. Attacks is an actual attempt that leverages a vulnerability to compromise systems. So compromising is attacking, right? Exploit systems. So compromise, exploit, these are similar terms. And, the actual attempt, remember the Stuxnet operation. This is a malware name, Stuxnet operation. There are many different types, as active attack, passive attack. Usually when we say passive, without changing anything, just watching the traffic or watching what's happening. An active attacker tries to manipulate the actual data or change, the information. That's the active. Insider, outsider, depending on where the attacker is sitting, local attacks or remote attacks, zero-day attacks or one-day attacks. So zero-day means zero-day. We have a zero-day vulnerability, meaning that nobody knows this vulnerability in the past, right? One-day vulnerability on the other side, it's known and the patch is available, but still, for some reason, the patch was not applied to this vulnerability in a system or software. That's the one-day vulnerability. Multiple vulnerabilities are often combined for a single exploitation. And for example, Stuxnet adopts 5 zero-day vulnerabilities. Okay. So risk can be computed based on all this together. Okay. So risk is the potential for loss, damage, or disruption to an organization's assets because of cyber attacks. And the risk, this potential can be leveraged by unknown or unknown vulnerabilities. And vulnerability causes threats, okay? And there are two different ways of risk calculation, but it's not that important. So just to think about risk, how you can, quantitatively measure risk. So risk can be computed by multiplying these three factors. One, threat, vulnerability, and impact. And the other one is asset, vulnerability, and threat. Okay, so both are correct, and depending on the objective, for example, if you want to focus on more likelihood of breach, then this equation is more popular. And if you want to compute the financial loss, then because there is a set inside the factor, so this formula is used. So the risk is sort of the concept that tries to quantitatively measure the threat, asset, vulnerability, impact, and so on. This is one example of a risk. The Microsoft defines the threat, and threat, these are the followed letters from here, DREAD, from damage potential, reproducibility, exploitability, affected the users, and discoverability. Okay, so we can ask, when we try to measure the risk, assess the risk, then how severe would the impact be, or how easy is it to reproduce the attack, How much work does it require to launch the attack? How many users will be affected? How easy is it to discover the threat, and so forth? Okay. Okay. So far, we talked about a few important concepts in security. This is a very basic thing to understand security, and I'd like to conclude this the introduction to computer security class with the introducing the actual topics that would be covered in computer security course. If you are interested in computer security, usually this course includes these topics. Security services and principles, software security in detail, system security, cryptography. If we have time, we also cover network security and web security. So the topics here with the stars on the bottom, privacy and anonymity and AI-assisted security is sort of an advanced topic. So I think it's unlikely, due to the time constraints, it's unlikely that the course can cover. But if we have a sufficient amount of time, then we partially cover, at least we can introduce what the anonymity and what are the AI assisted security part. Okay. So hopefully, let me wrap this up. Hopefully, throughout this class, at least you should be able to you should be able to understand what the security aims for, right? What are the major security services, including confidentiality, integrity, availability, authentication, authorization, access control, and non-repudiation, right? And what kind of basic concepts are there, right? To assess the risks using the threats, assets, and vulnerability, and so forth, right? All right. That's it for today, and thank you for your attention.